So today we're talking about systems of equations. This is going to be one of the last topics that we have to cover before our Module 3 test. So systems of equations is basically two or more equations that have the same values. So two or more equations with the same values. When we want to find the solution, we'll typically either go algebraically or graphically. Graphically is graphing. And when we graph, it'll be where the two lines intersect. Or we could say meet, or we could say cross. Algebraically would be where both equations are true at a given point. Now we have three different types of solutions down here. One solution would be where our lines intersect or meet. So it would look something like this. Try and change the color. There we go. So it would look something like that. Parallel, we know parallel means railroad tracks. So our parallel lines would look something like that. And the last one, same line, is just as it sounds. We would have one line, and we would have another that would ideally be right on top, but it doesn't look like I can get that. So we'll do it manually. So another line would be in the same place. One solution, if we only have the one solution because lines intersect, then that is my solution. So it would be the point x comma y, which we could say is going to be like -4 comma 3 or -12, 24. It's whatever point it is that they cross at. No solution is pretty simple. No solution. And infinite is also kind of simple. It's infinitely many solutions. So when we come down here to graphing, the first thing we need to do is put it into slope-intercept form, which remember that is y equals mx plus b, where b is my y-intercept and m is my slope. So let's go ahead and solve for line 1. (2x minus y equals -5). So the first thing we want to do is move everything away from y. For this one, that means I'm going to move my 2x to the other side with subtraction. And I now have -y equals -2x minus 5. Now I need to get rid of that negative sign next to y, which means we're going to divide by -1 on all of them. And that'll cancel out my negatives. So now I have y equals 2x plus 5. We'll do line 2 over here. Line 2 is going to be a little bit more simple. 2x plus y equals 1. Now, solving into slope-intercept form is probably going to be the hardest part of this lesson. It will be one of the more difficult parts of systems of equations. So if you can do this, then you should be fine with everything else. Otherwise, we need to talk about getting you to this point. What I'm going to do, again, is move everything away from y, which means we're going to minus 2x on both sides. That cancels out. And I am left with y equals -2x minus 1. So now we just need to graph it. which I need to rewrite mine over here so I can see them. Line 1 is y equals 2x plus 5. Line 2, y equals negative 2x plus, minus 1. Minus 1? This should be plus 1. Don't know how I got minus. I'm also going to graph line 1 in blue. Line 1, that's plus 5. And line 2 we'll do in red. Or purple, because it won't change to red. There we go. So now we can see our color difference in our lines. Line 1 says to start at -5, because remember, -5 is our y, positive 5 is our y-intercept. So we go up to 5 and we're going to put a dot. And then this is technically 2 over 1. And since this number is positive, we know we need to go up the hill, which means we are going to go up 1, 2, and to the right. 1 up, 1, 2, and right. 1 up, 1, 2, right, 1. If you wanted to go down instead, we would go down 2 and left 1. Down 2, left 1. Down 2, left 1. We could continue that pattern further. And then let's go ahead and put our line through it. The more dots you do, the more accurate your line will become. According to Algebra Nation, you only need 2 lines to make a graph, 2 dots to make a line, which is correct, but 3 is going to help make sure that you didn't screw up. So I always prefer 3. Now let's go ahead and graph the second line. So we're going to start at plus 1, which is positive 1. And this one is a negative slope, which means we need to go down the hill. So now I'm going to go down 2 and right 1. Down 2, right 1. Typically, we always go right as long as we can. So we're going to go down 2 and right 1. So notice every time I'm going to the right. When I graphed up here, I also always went to the right. If you wanted to do the reverse, then everything would be reversed. So we would go up 2, left 1, up 2, left 1. And then again, we graph. Now, the next question is, what do you notice about the point 2, 5? So -2, 5 over 2 up 5 right here. Well, that is a solution for my purple line. And my purple line is line 2. So this is a solution for line 2. What do we notice about the point 1, 7? I go over 1, I go up 7. That's a solution for my blue line, which is line 1. What do I notice about -3, 1? If I go over -1 and I go up 3, that's a solution for both of my lines. And since it's a solution for both lines, that means that it is also our solution to the system. And then the last one is 1, 1. So if I go over 1 and up 1 right here, that's a solution for nothing. So we can just say no solution. So let's do the next one. This one is talking about substitution. So again, for right now, we don't really need to reorder the problem, but we do need to plug stuff in. So this asks, is it a solution for either line? So let's find out. Line 1 is 5 times our x plus 2 times our y equals 8. Now, instead of our x and our y, I'm going to fill it in with the numbers that they gave us. So -2 and 5. And now we're going to solve. So what is 5 times -2? -10. What is 2 times 5? 10. And we're still seeing, does it equal 8? -10 plus 10 gives us 0, which definitely does not equal 8. And since it does not equal 8, then line 1 is not an answer. Now let's try line 2. We would have -3 times our x minus 2 times our y will equal -4. And we're going to plug in the same numbers, so -2 and 5. -3 times -2 gives us 6. -2 times 5 gives us -10. And 6 minus 10 does give me -4, which means this. Line 2 is a solution. So let's go ahead and check the second one. We're going to use the same equations, just this time different numbers. So again, line 1 is 5 times our x plus 2 times our y equals 8. Line 2 is -3 times x plus 2 times y equals -4. Oop, -2. Started copying the wrong one. And we're going to plug in 2 for x. We're going to plug in -1 for y, and now solve. 2 times 5 is 10, plus -2, which is the same thing as saying 10 minus 2, which is 8. And 10 minus 2 is 8, so that does work. The second one, -3 times 2 gives me -6. -2 times -1 gives me +2. And that will equal -4. So it is also a solution for line 2. Since it is a solution for both, that means it is also a system. And that is what we did today. Next class, we'll go a little bit more in depth into the solutions, graphing, and substitution.